Good morning, viewer. Biendas here has some breaking news. Quantum theory deals with events that occur on incredibly short time scales. In the past, these events were thought to happen instantaneously with no time in between. An electron orbits the nucleus of an atom and in the blink of an eye, it is certainly ejected by a flash of light. Similarly, two particles collide and are immediately quantum entangled. Today, however, scientists can study the exact timing of these nearly instantaneous effects. But researchers from TU Wien, Vienna, in collaboration with teams from China, have developed computed simulations to explore these ultra fast processes. These simulations allow us to understand how quantum entanglement forms in mere attoseconds. Their findings have been published in the journal Physics Review Letters. If two particles are quantum entangled, it makes no sense to describe them separately, even if you know the state of these two particle system perfectly well. But you cannot make a clear statement about the state of a single particle. You could say that the particles have no individual properties. They only have common properties. From a mathematical point of view, they belong firmly together, even if they are in two completely different places, explains Professor Zosim Bar Godefroy from the Institute of Theoretical Physics at TU Wien. In experiments with entangled quantum particles, scientists are usually interested in maintaining this quantum entanglement for as long as possible. For example, if they want to use quantum entanglement for quantum cryptography or quantum computers, we, on the other hand, are interested in something else, in finding out how this entanglement develops in the first place and which physical effect play a role on extremely short time scale, says Professor Eva Brezhinova, one of the authors of the current publication. The researchers looked at atoms that were hit by an extremely intense and high frequency laser pulse. An electron is thrown out of the atom and flies away. If the radiation is strong enough, it is possible that a second electron of the atom is also affected. It can be shifted into a state with higher energy and then orbit the atomic nucleus on a different path. So after the laser pulse, one electron flies away and one remains with the atom with unknown energy. We can show that these two electrons are now quantum entangled, says Zosim Bargodoffer. You can only analyze them together and you can perform a measurement on one of the electrons and learn something about the other electron at the same time. Be in this exclusive report.